At the dawn of the machine age, a new kind of giant began rising in factories across the world. Massive hydraulic forging presses. Some were so large that grown men standing beside them looked like action figures, towering 8 stories high and anchored deep into concrete and bedrock. They did not feel like machines. They felt like buildings. In a single stroke, they could drive incredible force into red-hot steel. Workers stood just a few steps away, feeling the heat and vibration through the floor beneath their feet. But when the press began to close, there was no warning signal and no way to stop it. Only a few feet and a few seconds stood between the men and thousands of tons of crushing force. This is the story of the hydraulic forging press giants. Fortunes were made, lives were crushed, and their surprising role in the Cold War helped shape the world that followed. To understand why the press was even built, you have to start with the failures that no one else could see. In the mid-1800s, factories faced limits their existing tools simply could not solve. Steel parts were getting thicker and larger, but the old methods only worked on the surface, leaving hidden flaws that would eventually surface later. Steam hammers were powerful, but inconsistent. They shook entire buildings, wore out the workers nearby, and even after countless blows, cracks could still form deep inside rails, artillery, and ship parts, setting up failures that arrived long after the work was considered finished. That problem forced a different kind of thinking. In 1795, Joseph Bramah proposed a new idea, using liquid pressure rather than impact to apply force. The point was not just power, it was control, allowing pressure to be applied evenly and steadily instead of through repeated hits. In the 1860s, engineers like John Haswell began applying this idea to forging. One steady press could drive heat and pressure through an entire steel block, strengthening its internal structure instead of only shaping the outside. This shift happened out of necessity, not merely a desire for improvement. Railroads were expanding, artillery was growing heavier, ships were getting larger, and the demand was for parts with fewer hidden flaws and less wasted material. Speaking of necessity and improvement, if this kind of industrial story is something you enjoy, I would be truly grateful if you could subscribe and let me know in the comments what kind of stories or disasters you would like me to investigate next. Now, let's get back to the action. Early forging presses could apply several thousand tons of force in one controlled motion. They reduced excess machining, cut waste, and made parts more reliable, giving factory owners a practical way to keep pace with demand. But they also created a new kind of risk. Because this time, the force did not arrive as blows you could anticipate the way a steam hammer did. It arrived as one continuous closing motion. And once it started, it did not stop. That single change rewrote the forge floor because the violence did not vanish. It simply became more controlled. By the 1880s, that control was no longer just an idea. It was steel, concrete, and pressure, all scaled to industrial size. Forge shops housed machines larger than the buildings around them. Steam hammers weighing more than 1,000 tons ran day and night, cracking walls, loosening bolts, and placing constant strain on the men who worked beside them. The hydraulic forging press marked a clean break from that approach. It did not rely on repeated impacts. Instead, it pressed down in a steady, controlled motion driven by enormous steel castings, some weighing hundreds of tons. The press itself required specialized equipment just to assemble it. The force came from pressure, not movement. Hydraulic systems stored energy inside sealed cylinders, building up thousands of pounds per square inch before anything moved. When that pressure was released, it acted evenly, without the shock or noise of a hammer blow. One single press stroke could accomplish the work of dozens of hammer impacts, shaping a hot steel block in one smooth, deliberate action. By the late 1800s, some factories had eliminated entire rows of hammers, producing forgings with fewer hidden flaws and far less waste. But this method brought new risks. In cold weather or under heavy loads, hydraulic systems could freeze or seize. Workers were sometimes forced to heat pipes, loosen fittings, or work near stored pressure that had not yet been released. As hammering faded, forge floors grew quieter. But the new dangers were harder to spot. The force was no longer sudden or loud. It was constant and concealed, working silently inside spaces built around thousands of tons of steel and stored energy. And once factories committed to that kind of force, they had to do something even harder than building the press. They had to build the ground beneath it. The press was not simply installed inside a factory. The entire factory essentially had to be rebuilt around a foundation. By the early 1900s, the main challenge was not just building the forging press. It was keeping it stable once fully assembled. The weight made ordinary factory floors unusable. So the first work was not skilled fabrication at all. It was excavation. Builders had to dig deep foundations before installing any major components. Some presses stood over 80 feet above the floor, with another 30 feet extending below ground. That was not over-engineering. It was the minimum requirement for stability. The lower sections were set in concrete and bedrock because lighter foundations could not hold the structure once force was applied. Factories had no choice but to adapt entirely. In many cases, the press became the center around which the entire plant was designed, with walls, cranes, and power systems arranged to serve a single fixed machine. The building did not house the press. The building served it. Structural integrity depended on massive vertical columns, each as wide as a large tree and longer than most residential buildings, forged from alloy steel and heat-treated in furnaces exceeding 100 feet in length. These columns were built to withstand sustained loads without failure. But a single hidden flaw in one column could bend frames, crack foundations, or redirect force into areas never meant to bear it. And the frightening part was that you would not always know, not until the press finally took a full load. The workers understood the stakes early. They watched hundreds of tons of molten steel poured into molds, knowing the machine being built would soon dominate the space and test the ground itself. The press was not simply installed on a site, it was permanently anchored to the earth, not by choice, but by necessity. Though, once set, everything that followed had to live with it, including the men. By the 1950s, the scale was no longer experimental. It was operational, controlled by a single human hand. At facilities such as Air Force Plant 47 in Cleveland, one operator stood at the controls of a machine capable of forces no human body could withstand. The control mechanism looked almost absurdly simple. Engineers later noted that the press responded instantly and precisely to a lever just 3 inches long. That was the unsettling part. How little effort it took to command so much power. That small movement controlled a system capable of exerting up to 50,000 tons of force. Around it were components of staggering scale, nuts over 50 inches wide, some weighing more than 50 tons, single pieces heavier than entire workshops from the previous century. Once the pressure started, it could not be stopped. The press moved steadily, squeezing hot steel as workers watched from a safe distance. It did not slam. It did not announce itself. It simply kept close. Do you have any experience operating or working around these incredible machines? If so, please let me know in the comments. The real heroes of this story deserve to be recognized. The operator needed no physical strength to guide the press. He trusted every valve, zeal, and casting to perform as designed. But the system did not care about his confidence. It cared about tolerances. Inside the press hall, the quiet itself was striking. Thousands of tons moved at the touch of a 3-inch lever, and everyone present understood exactly how close things were to going wrong. If something failed, it would not fail loudly at first. It would fail silently until there was no room left to move. But the operator was not the one closest to the danger. The closest men were those who had to step underneath it. The lever controlled the force. The floor crew lived inside its timing. The most dangerous place in a forge was no longer the furnace. It was the area directly beneath the press. When the dies were open, the gap could stretch over 15 feet and the table below was as long as a railroad car. It looked like open space. In reality, it behaved like a trap. In that space, workers moved red-hot steel into position using hand signals and shouted instructions. They stood just a few steps from the die faces, knowing that once the press began its stroke, there was no meaningful way to stop it or escape it. They were not just watching a machine. They were timing themselves against it as if their lives depended on it, because they did. The work followed a fixed routine. Steel was heated, pressed, reheated, and pressed again, sometimes several times in a single job. Pumps filled accumulators, valves were checked, and every step had to occur in precise order to maintain control. The routine only felt safe because it was familiar. But that familiarity was its own danger. a thin margin that one mistimed movement could erase. One mistake in timing could trap a hand, a tool, or an entire worker between moving parts that would not pause for any reason. Once it started, it finished. An oral history from Bethlehem Steel captured the situation plainly. A safety supervisor said that safety measures only worked when management stood fully behind them. Otherwise, they were just words. The press did not negotiate, only the schedules did. The press did not care how experienced a worker was. It operated on position and force alone. To work safely beneath the dies, workers had to follow procedure, communicate clearly, and trust that every system around them would hold. And trust was the most fragile part of the entire setup. When the press closed, everything went quiet again. Workers waited for it to open, confirm the cycle had completed, and then did the same thing they always did: step back in, lined it up, and hoped nothing had changed. Even so, demand did not slow. It escalated. Because once industry understood what these presses could do, it wanted more and larger. Aviation was among the first industries to make the shift. Press-forged parts distributed stress along their internal grain structure, allowing them to flex under load without fracturing. By the 1930s, aircraft manufacturers were ordering forgings weighing tens of thousands of pounds before machining, components that only the largest presses could produce. And once an airframe was designed around a specific forging, that forging became non-negotiable. The press did not just make the part. It dictated the geometry, the schedule, and the entire supply chain behind it. Civilian shipbuilding and heavy manufacturing followed the same pattern. Large presses enabled critical components with fewer joints, fewer fasteners, and fewer separate pieces that could work loose under repeated stress. Companies invested in press capacity because it reduced rework, reduced scrap, and reduced machining time. But every efficiency came with a trade-off: fewer alternatives when the press went down. As more industries built their designs around press-forged components, demand concentrated around a handful of plants capable of supplying them. By the mid-1950s, Air Force Plant 47 in Cleveland and Air Force Plant 63 in North Grafton were among the very few facilities with 50,000-ton presses capable of producing the large forgings that civilian manufacturers were now designing their products around. The press was no longer a symbol of industrial ambition. It was an obligation. And once the obligation exists, the next question is not how to build bigger. It is what happens when the press stops, or when the pressure that is supposed to be controlled gets loose. The greatest danger in a forging shop is not the heat. It is hidden force. A hydraulic press can appear completely still while holding enough stored pressure to bend steel and cause lethal injury. It can technically be off and still be fully loaded. In the years between the World Wars, shops with large presses became increasingly cautious during maintenance stoppages. Pump systems could build and hold approximately 4,500 psi inside sealed pipes, storing energy behind valves and seals that gave no warning before failing. The risk was not the motion you could see, it was the pressure you could not. Accident reports from OSHA revealed a consistent pattern. Workers were crushed while performing routine tasks, clearing scrap, aligning material, making minor adjustments. These tasks turned lethal when stored pressure released unexpectedly or the press cycled again without warning. The accidents did not happen during dramatic moments. They happened during the routine ones. Investigations cited missteps, inadequate guarding, and equipment failures, but the outcome was always the same. The gap closed. There was no time left. With a steam hammer, you hear it and you see it moving. You know when it is working. A press moves with almost no warning. It works slowly, steadily, and once it begins, it continues until it finishes. That is what makes it so deceptive. It does not feel urgent until it is already too late. The men who operated these machines understood precisely how dangerous they were. Even so, they came to work every day. Not because the danger was invisible, but because it was familiar. At places like Bethlehem Steel, workers felt both deep pride and a constant, steady awareness of risk. One worker said simply, "I was very happy to work at Bethlehem Steel. I enjoyed the work." That pride existed inside an environment where a single mistake could have permanent consequences. The rule was understood by everyone on the floor. The press did not make exceptions for anyone. working a large forging press was not routine labor. It took years of experience, accumulated knowledge, and learning from those who had come before. Workers described the machines as quiet and controlled, but never forgiving. A former press operator recalled how different the press felt compared to the old steam hammers, quieter, smoother, almost uneventful by comparison. That effortlessness was eerie. The machine's calm operation was itself evidence of its power, not reassurance of its safety. If anything, the calm made it easier to forget what was loaded and waiting behind the metal. Years later, supervisors and managers still spoke about forging crews with genuine respect, skilled, dedicated, proud of their craft. The job demanded careful coordination and disciplined procedure, not physical bravado. In that environment, discipline mattered more than daring. The press did not reward risk takers. It worked best for those who were consistent and methodical. For workers who learned to respect those limits, finishing each shift safely became its own mark of professional achievement throughout entire careers. Because the real accomplishment was not shaping steel, it was walking out at the end of the day. But pride did not make the work safe. Safety came later. After injuries accumulated and excuses ran out, forging presses were built for power, not for safety. Most of the safeguards that were eventually added came only after accidents made their necessity undeniable. The rule book, in other words, was written in blood. Throughout much of the early 20th century, production priorities outweighed safety considerations. Protective guards were limited. Procedures were loosely defined. Responsibility for safe operation often rested with foremen who relied on experience rather than formal guidance. That worked until it did not. At facilities like Bethlehem Steel, injuries accumulated steadily over time. Many accounts describe workers who understood the risks, but also understood they were expected to maintain production. Safety meetings were held, but without consistent backing from senior management, they carried little weight when deadlines tightened. And when the schedule tightened, the safety margins disappeared first. A safety supervisor put it plainly from hard experience. It may take longer to do it safely, but you will always be ahead of the person who did not bother. In the 1940s and 1950s, companies began adding physical barriers, lockout procedures, and tighter rules for maintenance and adjustment work. These changes often slowed production, sometimes slightly, sometimes significantly, and workers did not always accept them immediately, because every new safeguard was also an admission. The old way had been costing people their lives. Even with those changes, the presses remained dangerous. Fresses remained dangerous. There was no way around that fundamental reality. Machines capable of tens of thousands of tons of force cannot be made completely safe. They can only be made less lethal. Following the rules was essential. Breaking them still led to serious accidents, not because workers were reckless, but simply because they were too close to something that did not distinguish between steel and flesh. The safety measures that eventually became standard were not precautions added out of abundance of caution. They were responses to machines that had already shown repeatedly exactly what they were capable of doing to a human body. And even then, the machine never changed. Only the rules around it did. But then the stakes changed again, because these were no longer just factory rules. They became national priorities. After World War II, investigators examining captured German aircraft noticed a consistent and troubling pattern. The major structural forgings were lighter, stronger, and more uniform than comparable Allied components, produced as single integrated pieces rather than assembled from multiple sections. This was standard German practice, and it meant something deeply uncomfortable. Superior aircraft could be produced by nations with superior presses. The discovery caused immediate concern at the highest levels. Intelligence soon confirmed that the Soviet Union had seized Germany's largest forging presses, including machines capable of tens of thousands of tons of force, and had relocated them eastward. To American officials, this represented a fundamental shift in industrial power, not merely the transfer of equipment. In the early 1950s, the United States launched the Heavy Press Program. One of its centerpieces was a closed-die forging press rated at 50,000 tons, installed at Air Force Plant 47 in Cleveland and placed into operation in 1955. The goal was not rapid production, it was controlled capability, the ability to produce the largest aircraft structural components on demand. These presses could shape aluminum and titanium pieces weighing over 200,000 pounds before any machining. The finished parts were intended for bombers, transport aircraft, and future designs still on the drawing board. The press was being built for planes that did not yet exist. That is how strategic the calculus had become. The press itself became a component of national defense planning. Keeping it operational meant keeping entire fleets capable. When it went down, capability went down with it. Quietly, the forge had become a front line. And unlike the aircraft it supported, the press did not deploy. It stayed exactly where it was, anchored, permanent, and waiting. That permanence is the final, strange truth of the hydraulic forging press. It was built to move metal, but it could never move itself. Even after the workers who poured its foundations had retired or died, the presses remained exactly where they had been installed. Buildings grew up around them. Factory layouts were determined by machines that were never meant to be relocated. They did not just outlast the men who built them. They outlasted the era that required them. Each press was constructed from components of extraordinary scale, massive steel castings, some so large that dedicated foundries were required to produce a single piece. These components were designed to endure for decades, not to be replaced frequently. Once the steel was set, it was meant to stay set. Work routines adapted to this permanence. In some factories, the press determined where the walls went, how the overhead cranes moved, and where workers could position themselves safely. The factory did not contain the press. The factory arranged itself around it, shaped permanently by the limits imposed by a machine that could never be moved. Operators today describe experiences that echo those of the workers who came before them. The presses still respond smoothly to their controls, closing steadily and requiring the same level of care and attention they always have. The controls feel effortless. The consequences never did. These machines are quieter now than the forging methods they replaced. They still move slowly, deliberately, and the people working near them remain cautious, knowing that the same motion that shapes metal with such precision can cause serious and permanent harm with equal precision. The danger did not disappear. It simply learned to be quiet. If this story has stayed with you, please share it with someone who should hear it. Leave a comment. Tell us what you took from this and where you are watching from. Subscribe and turn on notifications so you never miss the next story. These machines shape the aircraft you fly in, the ships on every ocean, and the weapons that defined a half-century of geopolitics. The men who worked beside them deserve to be remembered. Now, at least they are.